Hello, everyone, and welcome to another event of the Pint of Science Netherlands online, Pint House. I'm a familiar face already at this moment, I suppose, but I'm Guilherme. I'm currently in Groningen, and I'm here with Helena.
Hi, I'm Helena, relatively new to Pint of Science Netherlands, but it's already my second event, and I'm in Amsterdam.
And tonight we have a great event. I want to invite Katya Frantseva. She's on the Department of Astronomy here at the University in Groningen. She also does other events in the Astronomy on Tap. Hi, Katya, and
hi.
Cheers.
Cheers. I got my.
Cheers.
What? Cheers.
Welcome to this evening. I hope everyone is also as excited as I am for tonight. And I suppose the floor is yours.
Thank you very much. First of all, I would like to say thank you very much for inviting me tonight. It's really nice to talk about my favorite things in science that I do every day. And also it's a bit unusual because as you said, I'm part of the team of Astronomy on Tap. So usually I'm on the other side, not not presenting, but just being behind the screen, doing promotion and things. So yeah, shout out to my team of Astronomy on Tap Groningen. Hi guys, I know that some of them are watching, so it's really nice. And so my name is Katya Frantseva. I work at the University of Groningen at the astronomy department, and I'm a postdoctoral researcher. I got my PhD at the Space Research Organization of the Netherlands. Originally, I'm from Ukraine. That's where I got my bachelor and master degree in physics and astronomy. And now I'm here in the Netherlands. And today I would like to talk to you about planetary carriers. So I was thinking about some nice, catchy title. And a couple of days ago, I thought, I'm going to check if someone already talked about something like that. So I Googled planetary carriers, and that's what I found. And I was like, that's really not what I'm going to talk about tonight. So if some people in the audience were expecting that I'm going to talk about some engineering parts, I'm really sorry to disappoint you. I'm going to talk about something more like this cartoonish image here, but not cartoonish, but more like real life. So I'm going to talk about asteroids and comets. And well, asteroids and comets, they are best known to us as heroes to frightening newspaper headlines. So you know all this, like you open your favorite, well, maybe not your favorite, but you open some news in the morning and you read, oh my God, this asteroid is going to kill us, I don't know, tonight, in a week, in a month, sometimes in a year. But that's usually how you hear about asteroids and comets. Mostly this one actually is about asteroids. Comets, they have been quite frightening in the past. And today they're mostly known for their beautiful tails. And I have to admit, they're really beautiful, amazing. It's just, if you've seen a comet with your own eyes, I'm pretty sure you will never forget it. But what I would like to say is that asteroids and comets, they're much more than that. They're much more than just titles of frightening newspapers and just beautiful tails in the skies. So if we talk about solar system, because that's where all asteroids and comets live, also again, if you Google it or just maybe you ask some of your friends or colleagues, usually the image of solar system that comes to your mind, it's like, okay, we have the sun, our star, and we have 8 planets orbiting around. And so here to scale, I'll also show you the distances, and you see that Earth is located at 1 AU, that stands for astronomical unit, and that's distance between Sun and Earth. And then all distances within solar system, they are measured in astronomical units, because that's much easier than talk in terms of kilometers, for example, because then it would be millions of billions of kilometers. That's just not very handy. So we talk in terms of astronomical units. So you have Earth at 1 astronomical unit, you have Jupiter at 5, and then the last one you have Neptune at 30 astronomical units. Some people, let's say probably a bit older people, will say that we always have also place in our hearts for Pluto, because I mean it's there, and it also got a heart. So how can you? Yeah. But anyway,
I was actually gonna say that. I was gonna say, where's Pluto?
Yeah, it's always there in our hearts. Cute and really nice. But what I would like to say is that that was not the whole image of the solar system, because we have a lot of small bodies orbiting our sun, and these are asteroids, Kuiper Belt objects, and comets. So you see that between orbits of Mars and Jupiter, you have main asteroid belt. Then outside of the orbit of Neptune, you have Kuiper Belt, and you see that Pluto is actually within this Kuiper Belt. And then surrounding the solar system, we have Oort cloud. And you see that the Oort cloud is located at the distances between, on scale 1 to 10,000 astronomical units. So it's really, really far away. And but this is actually also not the full picture. So these are the, let's say, main populations of asteroids and comets that we have in the solar system, but there are also a lot of smaller subpopulations. So you have, for example, near-Earth asteroids that orbit around Earth. Well, not around Earth, sorry. That orbit, that their orbits, they, let's say, cross orbit of our planet. So they come relatively close, and that's why also many scientists are particularly interested in them. We also have populations of Trojans that are orbiting at the same orbit as Jupiter, but one group of Trojans, they're running ahead of Jupiter, and another group of Trojans running behind. Then we also have, yes.
Can I ask you a question?
Sure.
So
yeah.
Why are they called Trojans? Is there a reason for that?
Yeah, so and here I will my answer will be a bit embarrassing, but I think it's something from the mythology that.
Yeah, I was actually thinking that.
Yeah, so it's like that. Okay, no, I'm not. I don't remember anymore. So my mom used to tell me all the mythological stories that are related to planets and different bodies, and also stars, constellations, but I don't remember. I'm really sorry.
I was wondering if it's related to the Trojan horse, where they built this huge horse and they tried to smuggle people in the horse into another city to take it, basically. But yeah, maybe not. I will check it later.
So I'm not sure that it's actually about the horse, but if I remember correctly, then it's actually related to Trojans, to the city of Troya.
Yeah.
But yeah, I'm not 100% sure. Actually, maybe. No, now I have some vague memory that actually the ones that are running ahead, they have one name. The ones that are running behind, they have a different name, and that's actually related to the story. But yeah, we can check later. Sorry about that. Yeah, so just to highlight, our solar system is not just our sun and planets, but we also have a lot of asteroids and comets, and we also have, sometimes we call them all together small bodies, or we also call them minor bodies. So if during the talk I will say small bodies or minor bodies, then just remember that that's like a group name for asteroids and comets all together. And just a general, also about asteroids and comets, they are also sometimes referred to as leftovers from planet formation. So basically these are chunks of rock and ice that, the same as the material that all the planets were formed from, but it's just that these are the objects that never made it into a planet. So, like you have, we were a couple of months ago, we were putting laminate floor in the home. And so we bought a bunch of boxes of laminate. And then, that we ended up having 3 rooms fully with laminate floor. So we can call them 3 planets. And then we got a lot of these like cutouts. So these cutouts, these are your asteroids and comets, and the laminated rooms, these are your planets. So that's also how you can think about it. So the cool thing about asteroids and comets is that when you study them right now, you can learn something about the past of the solar system. So because when these bodies, they came together and they created planets, all the material went through a lot of processing, so a lot of thermal processing, etc., which is also very interesting to study, but it doesn't tell you that much information about what was happening at the very beginning. So that's one of the reasons why asteroids and comets and all these populations of small bodies, they're so interesting and why they're actually important to study. So a little bit about asteroids. They come in different shapes and sizes. And so here, that's the image of asteroids that were directly imaged by spacecrafts that were either passing by or they were actually sent to study them as a main scientific
Yes. The object.
Yeah, the main,
object is better.
The main scientific object. So you see that the pictures, they're all not to scale. So for example, you have Vesta, and the radius of Vesta is around 250 kilometers, but here it looks tiny. And then you have, for example, asteroid Eros, that looks more like a potato than an asteroid. Well, it's an asteroid that looks like a potato. And its radius is only 8 kilometers. But yeah, they're all very interesting. They're all very different. And so, for example, also here you have on top Ryugu and Bennu. And these are two, let's say, the currently the most hot asteroids in terms that they're both studied by a space mission, and two different missions. So Ryugu was studied by mission Hayabusa 2, which is currently on the way back to Earth with samples of the asteroid material, which is really, really cool. So can you imagine that some years from now, scientists will receive materials of asteroid and they can study them in the lab? That's really, that's super exciting. And asteroid Bennu is studied by a mission OSIRIS-REx that also is collecting material from this asteroid and will also return it to Earth, well, hopefully, because with space mission, you never know, many things can go wrong. But when they, I don't know, I think it's just also extremely fascinating to think about creating a space mission that then actually flies to space and then does all the research, takes different data, pictures, and just gives us all the information. I think it's, just incredibly fascinating.
I actually have another question already.
Yeah,
sorry.
Yes.
So because they are all different sizes, is there like an upper and a lower limit? What constitutes an asteroid? So at what point it's too big for an asteroid, or at what point it's too small for an asteroid?
That's a really good question. So if we talk about asteroids that are in the main asteroid belt, and so here you see the kind of schematic picture of the solar system, and it's it's a picture face on of our solar system, and the scale is on astronomical units. The gray circles are giant planets. So J is for Jupiter, S for Saturn, U Uranus, and M is Neptune. And then inside the red belt, it's the location of the main asteroid belt, and we are actually inside there, inside. So if we talk about asteroids that are located in the main asteroid belt, and that's usually what we refer to, the largest one is called Ceres, and it was, Ceres was discovered, I think, in the 19th century by an astronomer that was called Giuseppe Piazzi. And so that was the very first asteroid discovered, and the size of Ceres is around 950 kilometers. And actually, Ceres is the largest one. And nowadays, Ceres is considered to be a dwarf planet.
Mm-hmm.
Yeah. For example,
it's like a new Pluto.
Yeah, just actually not like new Pluto, but so that's a new that's a different type where of objects in the solar system. So, for example, Pluto is a dwarf planet, is considered to be a dwarf planet nowadays. And Ceres is also considered to be a dwarf planet nowadays. But that's the largest object in the main asteroid belt. And then if we talk about smaller sizes, then I think that according to the International Astronomical Union, there is a definition that asteroid will be everything down to, I think, 10 meters size. And then if you go from 10 meter size and smaller, then this will be called meteoroid. Then if you go to micrometer size and smaller, then it will be called, then it's dust.
I wanted to say, like, at what point is it dust?
I think that from, millimeters, no, probably, from millimeter size, that's already, or micrometer.
Mm-hmm.
Yeah, that depends. I always get this kind of questions when I give lectures about asteroids to students at the university. They always ask me, they were like, but so what is the board? And I'm like, let's okay. But around, let's say, millimeter size or micrometer size, that's already dust.
Mm-hmm.
So these were asteroids. And here I have a picture. So that's the amount of asteroids discovered in up to 1997. And so, I don't know how much you can see, but there is a bit of green dots around. Well, it's actually quite a lot. So the second number on the bottom left, I think it's left. So next to 1997, so you see it's 34,000. So that's the number of asteroids that was discovered in 1997.
And in blue are the inner planets.
Yes, exactly. Yeah. And so actually also what you maybe can see a little bit. So you see that the belt of green dots, that's the main asteroid belt. And then, inside there is a bit of red dots. And red dots are near-Earth asteroids. So these are the ones that they are orbiting, that their orbit is close to orbit of Earth. Let's call it like this. Mm-hmm. And here I have what happened 17 years later. So this is 2013, and you see already that the number of discovered asteroids is more than 600,000 asteroids. And here you can clearly see the main asteroid belt and the near-Earth asteroids.
And the circle was what we saw in the image before as this small red circle, right? In the middle.
Well, actually, in the, you mean when there was just like a schematic picture?
Yeah.
Yeah, so the red ring in the schematic picture, it's the, it's the green one here. Yeah, exactly. Yes. So this is until 2014. And in a little bit, I will actually show you what is the situation as of today. So March 2021. Yes, I still remember what is the day today. Okay, another population that I would like to say a couple of words about. And just one thing also, that asteroids from the main asteroid belt, they are mostly rocky. So because I will talk about a little bit about composition of all these bodies in terms of which ones are rocky and which ones are icy. So the asteroid ones, they're mostly rocky, but they still have some fraction of water. So there are some types of asteroids that they can have up to even 10% of water in their composition. So here I have Kuiper Belt objects. So these are objects that are orbiting within the Kuiper Belt. So this is outside of orbit of Neptune. And here you also can see Pluto. And these are all our artistic impression, while Pluto is based on the actual images from New Horizons. And these are beautiful images that are made by a friend of mine. He's a PhD student at our institute, Nick Oberg. he does really cool illustrations. So here is also a link to his Twitter, so you can follow him and check sometimes his illustrations. Really nice. The Kuiper Belt objects, there are largely consist of frozen volatiles. And so, let's say different ices, for example, water ice or methane ice or ammonia ice. And here, just to show you again where they're located. So this one is the blue belt. So these are Kuiper Belt objects that are outside of orbit of Neptune. And now we will move to comets. So these are beautiful pictures of comets as we all know them. So we have Comet Lovejoy, Comet Hale-Bopp, Comet 67P, or it's called Churyumova-Gerasimenko, and also Comet Halley. Yeah, the Churyumova-Gerasimenko is very easy to pronounce. So it was discovered by Ukrainians. So I'm very happy every time when I can say it properly, like say the entire name, because I know how to say it.
What does the 67P stand for?
It's the number. So when you discover an object, they all get first designation. So basically, comets have their own system, asteroids have their the other one. P stands for periodic, and 67, I think it's basically the number that it was discovered with. So it was number 67. Nowadays we have around 4,000 comets discovered. So some other ones that you will see, they will have the number 3,000 something, etc. What I would like to say about comets is that, comets were known to peoples in ancient times. And so, for example, in the past, it's very easy to spot a comet, right? Because when they come close to the sun, the surface layer starts to evaporate, and then interaction with the solar wind and solar radiation creates this beautiful tails of dust and gas that just flies away from the comet. And so it was easy to spot it. So that's why people know about comets for, I would say always. And they were not so well received in the past, because you know that comet was it was basically, if you see a comet, then something really horrible will happen in the future. But the situation changed around 16th century, because that's when Kepler came up with his laws of planetary motion. So that's when he said that all planets, they orbit around the sun on elliptical orbits. And also later, scientists realized that comets are actually just like planets. They also orbit around the sun on elliptical orbits. And so the, I would say probably first important, let's say, discovery about comets was made by Edmund Halley, who predicted that a comet that was observed before, that it would come back. And it actually did come back. And so nowadays this comet called in his honor, it's Comet Halley. And it's actually one of the great comets. And great comet, it means that it's so extremely bright that you can, when it comes close to the sun, it's so extremely bright that you don't need a telescope to see it. So you just see it with your naked eye.
Nice.
Yeah. And I also wanted to say a small story. So this is like a story of comets with humanity. And my personal story with comets started with Comet Hale-Bopp, the one that you see here in the center. And this comet was visible in 1997. So I was around 6 years old. And I remember that my parents dragged me in the night to see the comet. And I think that I didn't appreciate it that much at the time, because, you know, if someone drags you in the middle of the night, then you're like, please, can I go to sleep? But no, I have to say that I'm really grateful to my parents for showing it to me. Also, I know my parents watch our stream. So hi, mom, hi, dad. And it was incredibly beautiful. And the rare thing about, for example, comet Hale-Bopp is that the orbital period of this comet is a couple of thousands of years. So if you didn't have a chance to see it in 97, you have to wait a little bit. But better news, for example, comet Halley will come back in, I think, 2061 or around that. So it's not so bad.
We have a bit of time until it's here.
Yeah, I think maybe we can make it.
I don't know if we're gonna be allowed to go out of the house by then.
Let's hope so, please.
Yeah, I really hope so. But yeah. And here also I indicate actually what are the sizes of this comet. So basically the size of the comet is the size of its nucleus. So that's actually this body itself. So for example, on the picture of 67P, you see that's the image of the nucleus of the comet. So because this comet was studied by space mission Rosetta. And so you see that, yeah, there was also a lot of jokes about this particular comet because everyone was comparing it to a rubber ducky. It does look a little bit like a duck.
I was going to say dog.
Yeah. Dog?
Yeah.
Okay, maybe. I think I just saw it so many times compared to a rubber duck that just it looks like, yeah. But the size of this comet, the size of the nucleus is, the radius is 2 kilometers. And then also as comparison, you see that Comet Halley is 5.5, Hale-Bopp is 30, and Lovejoy is 0.25. So the nucleus, the sizes, the nucleus sizes of comets, they're not so large. If you remember, for example, the largest asteroids in the asteroid belt are on the Ceres is around 950 kilometers.
So if Hale-Bopp, for example, is 30 kilometers, does that also mean that the tail is then longer compared to, for example, Lovejoy, that is smaller in size in general?
So that's a good question. And I don't, well, in theory, I would say that if you have a larger size, then you also have a larger surface that is exposed to the solar heating. And then you have the larger surface that is from where the material is evaporating. So, yeah, I would say that, then the tail is larger for the larger one. And I think that actually a picture of Lovejoy was taken from the International Space Station. So it was, I don't know exactly if it was, I don't think it was visible actually with the naked eye, but maybe it was like some borderline visibility. But this particular picture is from the International Space Station taken by astronauts. So, yeah. And there was a really cool comet this summer. So if you were lucky to be, even in the Netherlands, I have to say, because this summer was had a lot of clear nights. So if you had a chance to just go outside of the city from all the light pollution, then around June, July, you should have been able to see a comet. It was called Comet Neowise. It was also very beautiful and really nice. And again, a bit of sad news, the orbital period of this comet is around 7,000 years. So if you missed it, let's...
I remember myself with my phone and those tracking apps trying to find it, but I'm in the middle of Groningen.
Okay. No, we went just a little bit outside of Groningen, and we were able to see it. And
I don't know if it was hidden behind some buildings and everything. I lost it. Maybe in the future I can see it.
There is a very nice. I think there are actually quite a lot of apps for the phone for stargazing. So just download a bunch of them, and they will do a great job of guiding you through the night sky and showing you different objects.
Actually, I think that after this presentation today, I'll just go look up when the next comet comes along because I need to see that.
So I think that if we talk about the comets that are visible with the naked eye, and if we talk about periodic comets, because for example, as you asked before, why the comet 67P is called 67P. So this one is called periodic comet. And so usually we refer to also comets according to the region where they come from. And so here I have a picture. And so we have comets coming from different places. So we have comets coming from the Oort cloud. So this is like, that's a sphere that surrounds the solar system, and that's the place where the comets are located. And so usually the comets that have very, very long orbital periods, they are coming from Oort cloud. And so on the orbital periods in the range of thousands of years. And then we have comets that would come from the Kuiper Belt. And then we also have comets that are called Jupiter family comets, and they come from the main asteroid belt or around that region. And so the comets that come from Jupiter family comets and the Kuiper Belt comets, they have orbital periods that are short. So for example, less than 200 years. So, and if you see the comet that's name is has a P in it, it means it's periodic. In terms that it has a relatively short period. So it can be tens of years or up to 200 years. And then you have kind of long period, well, not really periodic comets. And so these would have orbital periods of thousands of years. So basically let's say that they are located in the Oort cloud, and then if they're disturbed, gravitationally disturbed, so kind of gravitationally pushed, either by maybe a star that is passing by, or maybe interaction between themselves, then they can be gravitationally perturbed. So someone pushes them, and they enter the inner solar system, and they pass by Earth and the Sun, and so then we see them. And then when we calculate their orbital periods, we see that it's around thousands of years, and we know that they come from Oort cloud. So we probably never gonna, for sure we're never gonna see them again. So that's a sad and a not sad story of comets. And I also have to say that comets they contain a lot of different ices. So compared to asteroids that are mostly rocky, we can say that comets are mostly icy. And this is a website where you can, if you're curious, just go and check sometimes how many asteroids and comets were discovered this month or this year or all the time. And so you see the table in the right. We see that minor planets discovered all time. Now it's more than 1 million. Yes, we can celebrate. So that's the amount of asteroids and comets and Kuiper Belt objects all together that are discovered as of today. So March.
Katya, does it happen often that people think they discovered a comet, but then it wasn't really one?
I think what sometimes happens is that you may think that you discovered a new object, but then when you compare it to data in the catalog, then you see that it was an object that was discovered before. But then you have, so you have, let's say, astronomical surveys that are discovering, like the main scientific objective of this surveys is to discover new asteroids or comets. And then you also have a big community of amateur astronomers that are also do a great job of discovering new objects. And I think that actually, I want to say often, but it's also a strong word. So sometimes comets, for example, they are discovered by amateur astronomers. So that's also, thank you to the great community of amateur astronomers.
Do they then get to name the comet? Sorry.
No, I remember reading once that somebody made a discovery. I don't remember if it was an academic or an amateur, and it was something very different and everything for a comment or whatever it was, and then suddenly they had to retract the discovery because it was just Saturn. And they forget to cross-check with the planets, or Saturn or Jupiter or something like that. Like, oh yeah, forget about it. Yeah, it's just a planet.
So, but if you discover one, do you also get to name it?
I think that actually for comets, yes. So, for example, we will talk about comet Borisov that was discovered, I think, 2 years ago. And yeah, so it's called Borisov because that's the name of the person who discovered it. So I think that for comets, it works like that. But for asteroids, it's a bit different story. So there are really a lot of asteroids, and decision to name an asteroid, I think, is taken by International Astronomical Union. But then there is people can, let's say, propose that, I don't know, I want to name an asteroid after this city, or I want to nominate, an asteroid after a country. And I'm pretty sure that there is an asteroid called Groningen. I'm pretty sure there is an asteroid called, Amsterdam, Utrecht, Kiev, Ukraine. So all those names are already attached to some asteroids. But if you see somewhere online that they tell you, oh, pay us this money, we're going to name, a star or an asteroid after you, that's kind of a scam. I mean, if you want a nice certificate, you can go for it, but it doesn't really mean anything. So, yeah.
Good to know, though.
Yeah. Hopefully I saved someone's money, but so this was about the amount of asteroids and comets that are discovered so far, and big differences about where they come from, what is their different composition. And I wanted also to say, again, why actually we study all these small bodies. So as I said, because they tell us about the origin of our solar system. And it's very nice to study them, because we can study them not only in the sky to observe them, but we also can kind of get them in our lab. So, for example, you have an asteroid that orbits around the sun, and sometimes it happens that, these asteroids and comets, they also migrate. So they can also be gravitationally disturbed from their positions. And then through process of migration, so basically they kind of like a carriers, DHL, PostNL, they travel through the solar system, and sometimes they impact with planets, for example, with Earth. And so if an asteroid, a piece of an asteroid, so meteoroid, etc., enters Earth's atmosphere, then you see there's this bright streak in the sky, and you call it meteor. And then if this object was large enough, and it survived the passage through the atmosphere, and you find it on the ground, then you call it meteorite. And the cool thing about meteorites, you can just, you grab them, you go to the lab, and you study them there. So it's like you had an asteroid there, not directly like that, but then you observe asteroids in the sky, and then you also get meteorites to study in the lab. So it's very handy. It's also you get information about the origin of the solar system delivered to Earth for free. So you don't have to pay for the space missions. You don't have to do this planning. You have to be lucky though. So if you're not lucky, then.
And what kind of information do we lost during entry? Because everything is burning, right?
Yes. So actually, it's pretty. So I just have to say, I never worked in the lab with meteorites, so not first-hand information. But the idea is that when you have this body and it enters the atmosphere, of course, the outer layers, they heat up enormously, they start to burn, evaporate, they're also lost. But the modelings of there were scientists who were making models of how these different bodies of different size, different mass, different composition, how they go through atmosphere. And so for certain sizes, so let's say for relatively larger sizes of minor bodies that go through Earth's atmosphere, the very inner part is not heat up that much. So actually if the object is large enough, then the very inner part will be preserved without any heating and any alteration, etc. But still, you have to take into account that when you pick up the asteroid, if you pick it up at the moment when it just fall, and you immediately bring it to the lab, and then I don't know, you try to isolate it somehow. That's one story. But in many cases, as meteorites, they're just found. They're just found on the ground, and you can estimate for how long they were laying there, but then the amount, how the interaction with the atmosphere, etc. You don't get the information firsthand. So that's why, for example, it's very important and very exciting for astronomers that there will be pieces of asteroid. So from asteroid Ryugu, asteroid Bennu, that pieces of asteroid will be delivered to Earth, because then you can have these samples of asteroid material that didn't have to go through the interaction with the Earth's atmosphere, because of course it introduces some alteration to the material. So that there are always pros and cons, but
if a meteorite lands, doesn't everyone want it? So is there like a fight who gets it in which lab?
So you can buy meteorites on eBay, I think. Well, there are. I actually.
You have one.
Yeah, I have a tiny one. I don't know.
Aww.
So it's really a tiny baby. From one point of view, when I think about it, it's much better that this piece of asteroid or meteorite would have been in the lab, studied by scientists. But at the same time, I also look at it and I think, oh my God, this is like the oldest thing in the solar system that I can touch with my own hands. So it is very selfish desire to keep it on my desk, but I just, but so I think that there are people that actually are meteorite hunters, because you can also make money out of it, or if you're a researcher, then you're purely interested in research. But meteorites can be bought online, but you also have to buy it from approved sellers, because I think that sometimes it can be just scam, and then you get a nice piece of rock and you think it's a beautiful meteorite from outer space, but it's just a rock from near your garden. Sorry. That's one reason why we want to study small bodies. Also, the nice example that I would always like to say is that by studying small bodies and their locations in the solar system right now, we can infer to what was happening in the past with planets in the solar system. And so you can think about it in a way that we know that in the past, planets would also, in the solar system, planets would migrate, would move, and they would scatter these small bodies around. And so now, by finding small bodies in different locations, we can try and reconstruct what was the past movements of the small bodies, and respectively what was the movement of the planets in the past. And so an example here is an accident that happened with a big container full of rubber duckies that just fall into the ocean. And then in the later years, these rubber duckies were found in different places across the globe, so different shores. And by actually studying at which time, where and how many rubber duckies you found, you could, the scientists, oceanographers, were able to study actually winds and streams in the ocean, etc. So the same idea about small bodies in the solar system. You find these small rubber duckies in different locations, and then you can infer how planets so how gravitational interactions were throwing these rubber duckies around. That's also a lot of very interesting thing to study. They also help us understand more about the origin of life, because studies of asteroids, comets, meteorites, they show us that these small bodies, they contain water, and they also contain organic compounds. And so I have to say that here, organic compounds, it will be just anything that is, any molecules that are carbon bearing, but except for CO and CO2. And we know that for life as we know it, which is, well, so far the only life that we know it here on Earth, the main ingredients are carbon-bearing molecules, so organic molecules, and water. And so we know that these ingredients are present on small bodies. And so that's why we think that maybe these ingredients somehow were also delivered to our planet in the past. Because, for example, one of the theories of the planet formation tells us that maybe asteroids played an important role in the delivery of water to Earth. So, for example, because Earth was formed too close to the sun, well, let's say it was formed where it was formed, but it was just relatively hot. So it was so hot that any liquid water wouldn't stay in this region. And so if you go a bit further from the sun, then it's colder, then water can stay there in a frozen state, for example. And so the idea is that maybe when these asteroids, comets, small bodies were moving through the solar system, they were bombarding Earth and they would bring water. Another theory says that maybe actually the material that was forming Earth, like different chunks of rock, etc., that they contained, they were able to actually preserve water, and then from the water was released to the surface of the planet after the formation of the planet. So there are different theories, but what we know for sure is that asteroids, comets, all these minor bodies, they were bombarding our planet. And so even if they didn't bring all the water or etc., they still contributed to the delivery of water and organic material to our planet. And they also bombarded other planets, so also delivery of water and organics to other planets. And the bombardment is continuing even now, but just now the rate of this bombardment is much smaller.
I'm just imagining a lot of rubber ducks falling from the sky now.
It's not so bad. That's because I wanted to say that with the migration and bombardment, but the good part is, bringing water, organic material, but you also have the bad side, right? That if the object that bombards is large enough, then, well, it's threatening life on our planet. And so, for example, we know that extinction of dinosaurs was connected to the impact of asteroid of about, I think, 10 kilometers size around 65 million years ago. So that's another reason to study small bodies, just to discover them, to discover as many as possible the larger sizes, so the potentially hazardous ones. And so if we discover them, we know their orbits, we can calculate how their orbits evolve, then we can be prepared for any kind of eventuality, or at least we're going to know that something is going to happen, and then we can think about what to do about it.
And before we know, the news will tell us, probably.
Yes. But don't trust all the news about asteroids killing you. And another interesting thing about asteroids and comets is also that you can fly to them, because, well, they're not so far. So for science, of course, that we do. But also another thing that potentially can happen in the future, it's mining of asteroids, right? That's something that people have been talking for quite some time. So, of course, it was in science fiction, but there were already some companies that were trying to do some at least study trials of how to potentially mine asteroids in the future. So I'm skeptical about asteroid mining in near future, but I'm not skeptical about asteroid mining in some bit more distant future. And I think I have I prepared more things to go, but I think that maybe I could also stop here because that's just too much. So I would also love to answer any questions about comets, asteroids, planetary carriers, but only in terms of asteroid and comet delivery.
While people are thinking, maybe I have a quick question related to that. What kind of materials that are worth the hassle of going to an asteroid and coming back safely?
So I think that when people talk about asteroid mining, then they say that it should be the precious metals that we actually use in creating electronics. So because those, we don't use them in such large quantities, but for example, every phone needs them, and we don't have so many of them on Earth. So that's financial reason to go to asteroids. But I think that also another interesting idea is that we know that asteroids, there are some that are, let's call them water rich, that they can have up to 10% of water in their composition. And so then this kind of asteroid you can use as a refuel station for your fuel. So for example, you set up a refuel station on asteroid, so you use water for as a fuel, and then you refuel there, and then from there you hop on other asteroids, and you mine some other precious materials there.
I also had another question, because in the beginning you had a slide with all of the news articles. So I was wondering, how often does it actually happen that there's a really big one that might, possibly threaten life or threaten other planets? And how often does it happen that it appears also in the news that it's that big?
So, for example, 5 years ago, there was a meteorite fall over Russia, and that one made to the news because that one was, let's say, discovered that it will be impacting our planet only at the moment when it was kind of already impacting. So, but that one was not large. I think the size was a couple of meters, not more. So, and these kind of asteroids, or not asteroids, but more like meteorites, their falls are. So let's put it this way: the smaller the meteorite, the more often you have falls from them, and the larger you have, the less often you have falls from them. So, for example, the asteroid that is really connected to the extinction of dinosaurs, so it was size around 10 kilometers, and the fall happened about 65 million years ago. So I think that statistically, these asteroids of this size, they actually should impact our planet on average 1 per 100 million years. So it's 65 million.
We get some time.
So well, you know how statistics works, that you can maybe you have 200 million years in between, maybe you have much less, but I hope this answers your question.
Yeah, totally. I mean, I was just interested because, in fact, when you showed the slide, I knew that sometimes I had seen this like on news or on the internet, but I was really wondering how often that happens. But it makes sense, of course, that the larger ones don't appear that often.
Yeah. So, and also cool thing that the large ones, so there is a size threshold, let's say, for asteroids that are considered potentially hazardous. and I think it's 140 meters in size, I think. And the idea is that the asteroids of sizes 140 meters and larger, there are a lot of observational campaigns that are actually directed to, to discover, let's say, to try to discover all of them. And for example, if you look at the catalogs and we check for size of asteroids that are around 1 to 10 kilometers, so let's say asteroid killer, dinosaur killer asteroid. So the asteroids of those sizes, we know that we detected, almost all of them. So around 95% of all of asteroids of those sizes. So that's already good news, right? But then you still have smaller ones, like hundreds of meters in size. And then those are still potentially dangerous because they can wipe out a city or, that's kind of not still. It's very unfortunate. It's horrible if something like that happens. So we really have to be prepared. So that's why, people discovering asteroids that are protectors of the humanity in a way.
And we have a question here from Taichi. Says a great talk. You earlier mentioned that there were historical interpretations or omens for asteroids. You know anything that stick out?
I think I have some memory of no, I don't have. I don't know. I know that it was like really bad sun in the past, so that I don't know if you have a comet and then after that the crops are not really doing well, then that's of course the fault of the comet, because whose fault it is? That's the comet.
Yes.
Yeah. So, but I think that for sure there were some stories in history when, as was mentioned in the comment, that the war would stop, or maybe some other things would happen.
I had a related question to that, because I was wondering that if there are so many, let's say, things falling from the sky landing on Earth, does it somehow have an impact on like the ground or the water or the air? Or is it really, in that sense, just a rock that lands on Earth and does nothing? That could be interesting to study.
So for sure it has an impact, but then it depends on the size of this object. So if you have, for example, the meteorite that fall in Russia, in Chelyabinsk, around 5 years ago, it was not so large, so no one was killed. But then, for example, the shockwave from the atmosphere entry was so strong that a lot of glass was shattered in the city. So that's first thing that can happen. And then, for example, when the object impacts the surface, then you have so-called formation of the crater. So that's basically when the impact happens, and then a bunch of material from surface is elevated, and then part of it is evaporated, part of the asteroid is evaporated, then they mix up together, then they fall back, and then they create, it's called ejecta crater. So that's why you have the shape, you have like a hole, and then you have this kind of wings. So these wings, this is a mixture of asteroid material with the surface material. And then, of course, the larger asteroid you have, the larger impact you have. And for example, if your asteroid is very large, then a lot of material will go into, like a lot of dust will go into the atmosphere. And that's, for example, one of the fears when a big asteroid will impact the Earth. Then it basically will be like kind of similar to nuclear winter, that you will just have so much dust particles in the atmosphere that it will be maybe not breathable, but also that it will be not really transparent for the solar radiation anymore. So then, that's of course depends on the scale of the the asteroid. And then, for example, if you have a huge asteroid that falls into an ocean or sea, then I would say that it would create a huge tsunami wave or etc. So it does a lot of things, but depends on the size. So the smaller size you have, the less things are happening.
But so the way I understood it now is that they have more a physical impact in the sense that they move other things on Earth, or they, shatter. So I was meaning more things like I don't know, impacting the water quality, for example, or things that actually,
Okay.
or impacting how plants grow on the Earth if something had landed there. So do you know if they actually also can have effects on these kind of things?
Yeah, here I'm actually not sure. But for example, if you have an asteroid that hits the surface, creates crater, then all the vegetation there is just doomed, right?
Yeah.
So that's the first direct impact.
Also, like you said, there were like different elements, different ices.
Yeah.
So if it lands in a body of water and then starts to melt, maybe then this could contaminate that water, no?
Yeah, but then you also, well, in theory, yes, but still you need to have really a large one to have.
Oh, like, yeah, because it burns everything.
Yeah. So yeah. Like, I don't know, in order to contaminate oceans, you would need a really large asteroid. Yeah.
We actually have another question by Peter Jansen. And he actually also a question I had. He asked, what are your chances of getting hit by an asteroid when you're walking outside? So I was also wondering, how fast are they going?
So, for example, the velocities at which the asteroid or comet material enters the atmosphere of Earth can be between from 15 kilometers per second to 30, 45 kilometers per second. And but then when they go through atmosphere, they slow down, right? Because they have the interaction with the atmosphere, so they slow down a little bit, but still not cool. But what are the chances of you being hit by an asteroid or a meteorite when it falls? I think it's incredibly small. So, well, the chances of dying in a car crash are much higher. And if we talk about the entire history of humankind, at least the registered one, I know about 2 cases when a meteorite hit a person. So one was somewhere, I think, in 50s in US, and it was still not a direct hit. So a lady was sleeping at home, and the meteorite crashed through the roof. Then I think it ricocheted from her radio or something, and then it hit her. So it was not really direct hit. And I think the size of the piece was like about orange size. And then another one happened actually this year. One of my students told me about it. So I think it happened somewhere in Asia, but also, I'm not sure if the person was hit, but I know that the meteorite crashed through the roof of some person, and that was pretty precious meteorite because I think that's the one that has actually water and organic compounds in them, so it's more expensive one. And I think that someone, like some rich guy, bought this meteorite from this poor guy whose roof was crashed, but he's not so poor anymore because I think he got hundreds of thousands of euros for this piece. So I would say that it's not that bad to get a meteorite crash through your roof because you can get money out of it. So,
as long as you're not hit by it, I guess.
Yeah. Well, yeah, that one is not so fun. But if it's somewhere on the side, I don't know, on a foot or something, that's okay.
I learned so much today. I'm so excited. I'm just going to look up meteorites and everything after this talk. I mean,
yeah.
And maybe that's a good time to stop for the day.
Yeah.
Thanks everyone who interacted on the comments. Thanks a lot, Katya, for giving your precious time to us. Luckily, nobody got hit by asteroids during the call, but it would be quite remarkable in a presentation about it happening live.
Yeah, that would be interesting.
So thanks a lot.
Yeah.
Thanks, everyone. Stay tuned in our social media because we also have the main events of A Pint of Science worldwide going on. Not in an actual pub, unfortunately, but we'll be around. We power through it. Thanks, everyone. Have a nice evening.
Thank
Bye-bye.
you.
Bye.
Bye.